Hey, what's going on guys? In this video we are going to see how to do the proof by contrapositive, or you can say proof by contraposition. Now here we have, for all x belongs to real number, if 2x is less than or equal to 0, then x minus 1 is less than or equal to 0. Now first of all we have to know how to write the contrapositive. To write the contrapositive, what we do is we take the negation of this one, that's going to be after if, and take the negation of this one, that's going to be after then. So we just flip it around the negation, and if this is true, contrapositive also always true. So we just have to prove contrapositive is true. If we can prove the contrapositive is true, then it automatically means this also true. Okay, so here what we are going to do, we are going to take the contrapositive. Contrapositive is if x minus 1 is the opposite. If here it's less than or equal to 0, so this would be greater than 0, and then we write the negation of this one. This is going to be 2x greater than 0. Okay, now here we only have to prove this one because this is not changing. Like they are asking if this is true, then this one is true, so we just have to prove this one is true, and if we can prove this is true, then that's it. That's our final proof. If this is true, then it's gonna the given statement is going to be automatically true because we proved the contrapositive. Okay, now let's see what's going to be our first step. Here I'm going to use the axiom number 12. If you want to know the list of axiom, I put it in the description, so you can refer to that. Axiom number 12 says when you have x minus 1 less than 0, and if you add something to that, that should give the same thing. Like for example, if you add 1 to both sides, here I am adding 1 because I want to get rid of this negative 1, so add to 1 to both sides. Let me minus 1 plus 1, and here in the other side we are going to have 0 plus 1. So if you add 1 to both sides, that's equivalent. Like this also greater than this one. So here if you add 1, this is going to be x greater than 1. Okay, so this is our first step, and this is if we simplified this one by additive inverse. Negative 1 plus 1, that's gonna give us 0, so that's by additive inverse. Additive inverse, and 0 plus 1 is equal to 1, that's by identity of addition. This is by identity of addition. Now I also put the video I made on these axioms in the description, so you can watch that too. This one is axiom number 4. This one is axiom number 3. Okay, now we have this one. The next thing is we are going to use the axiom number 13. Axiom number 13 says when we have x is less than 1, and we know that 2 is greater than 0. So let's look at the axiom number 13. Axiom number 13 says, for example, if you have x is less than y and 0 is less than z, therefore xz is less than yz. Okay, so here you can see this cross is equal to this one. Now here we are going to do the same thing for this one. We know that x is less than, actually x is greater than 1. So we are going to write this in this pattern. Let's write this with a different color. So here 1 is, if I write it in the opposite way, 1 is less than x, and 0 is less than 2. 0 is less than 2. So from this one you can try to bring this pattern. X times z, 2 times 1, that's 2, is less than y times c, 2x. Right, so that's what we are using right here. This is axiom number 13. So since 2 is greater than 0, 2x is greater than 2 by axiom number 13. Okay, now this is our next thing, and after that we can use the transitivity. Transitivity says if this is true, then 2x is greater than 2. We found out that, and 2 is greater than 0. This is by transitivity. By transitivity, and then That's it. So from this one, if 2x is greater than 2 and 2 is greater than 0, therefore we can say 2x is greater than 0. And that's our final proof. This is what we want to prove, right? 2x is greater than 0. So we proved the contrapositive is correct. Therefore this is correct. And that's how we do that. I hope this helps. Thanks for watching, and don't forget to subscribe. And if you are trying to learn discrete mathematics, there are a bunch of videos in my playlist. I hope you guys watch that too. See you next time.